Hello, in this section we will look at more information about the linked list. The linked list class provides the operations for storing, searching, retrieving, and removing elements in a list. So we're going to define this linked list class, and we can create linked list objects using linked list objects to store the elements. Linked list is a popular data structure for storing data in sequential order. For example, a list of students, a list of available rooms, a list of cities, and a list of books all can be stored using lists. The common operations are the following: retrieving an element from a list, insert a new element to a list, delete an element from a list, find how many elements are in the list, find whether an element is in a list, finding whether a list is empty. So this is now the class. So the class, this T is the element type. So this is generic linked list class with this three data fields: head, tail, and the size, number of elements in the list. So this is the constructor, no constructor, constructing an empty linked list, constructed a linked list from another linked list. So this is the copy constructor. So this is the destructor. And this is the add first. You add elements at the beginning of the list, add last, add the element at the end of the list, add get first, retrieve the first element without removing it, get last, get the last element from the list, remove first, remove the first element and return the removed element, remove last, return the removed element, add a new element at the end of the list, add a new element at the specified index, clear, remove all the elements from the list, contains, test if this element is contained in the list, get index, using this index, get the element at the specified index, index of, find if this element is in the list. If so, return the index of the first matching element, otherwise returning -1. Is empty, is the linked list empty? Last index of, from the end, search backward, find the first elements that index. So if there's no match, returns -1. Remove the element, get the size, remove element at the given index, set a new value for the element at the given index. So this, we can talk about begin and end. You already know the begin and end when you use the vector, so you can get the iterator. So that's kind of a pointer to the beginning of the linked list. So this is the node. Given the linked list, we can write a test program. So this is the test program here. This is the main. So we're going to create a list for strings. So this is linked list for string. So please note that this is lowercase s is string here, and now this is the list. Add, so print list and see after you add it and print everything in the list. So we're going to see everything in the list. Add another one, add another one, add another element, and now add Germany to the list. So this is link list dot add Germany to the list. And this is the, insert the element here, string Norway, to this index 5 in the linked list. And this is the to insert at the beginning of the list 0, so Netherlands, and remove the first element here at index 0, and this is to remove the element at index 2. So this is to remove the element at the last one. It's the list.getSize -1. So this is the test program for this. That is all for this linked list class. In the next video, we will look at the implementation of the linked list. See you on the next video.